Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy is going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry, we'll be here next Wednesday night as well. So bring those questions with you if you want, and you could ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam Praxis peeps, big shout out to you guys out there too, and especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Everybody, welcome to Wednesday Night Math Night. As you know, if you've been here with me before, I absolutely love getting together with you guys on Wednesdays and just solving math problems to help you prep for your exam. So that said, I want to get to know the people in the room a little bit. So before we get started, let me know in the comments where you're from, what test are you prepping for, and who are you rooting for in the Super Bowl? I'm going to be quite frank. I don't even know who's in the Super Bowl. We are Cowboys fans, and I know the Cowboys did not make it into the Super Bowl, so I don't know who's in the Super Bowl. But if you know who's in the Super Bowl, who are you rooting for? If you don't know who's in the Super Bowl, are you even watching the Super Bowl? We will watch the Super Bowl in our home. We are celebrating my son's first birthday on Saturday. It's like his little party. And then we will watch the Super Bowl on Saturday or on Sunday. So one more note. Hey, Lauren, how are you? You're from Florida. Awesome. I'm from Florida too. I live in Central Florida. I'm an assistant principal here in Central Florida. And I love sitting here with you guys and doing math. You're prepping for the GK and the professional ed. Awesome. We will be focusing on the math today. In the comment section, please let me know if you have any specific questions for me. So if you have any specific questions or there's any specific topics that you're really struggling with, please drop them in the comments and let me know, or find me on Facebook or email me, either any of the above. My email is this. You can feel free to email me questions that you have that you want to see included in upcoming Learning Liaisons math nights. So let me know in the comments or email me and let me know what you want to see me work, because these kinds of sessions benefit you the most when I'm doing things that you need. You've got this, Lauren. It's not if you pass, it's when you pass. And I truly wholeheartedly believe that. The math is a hard exam. So you've got it. And if you're still struggling, feel free to sign up for tutoring with myself or Priya. We are both more than happy to help you because sometimes that one-on-one really helps. Hey, Joseph, good to see you. Eagles versus Chiefs. Thank you for that. That is helpful. Hey, Easter. Hi. Good to see you here. I will be chatting with you soon. Hey, Hope, and you're struggling with Comp 1 and Comp 2. So, Lauren, I will make sure I include some Comp 1 and Comp 2 questions in the coming weeks to specifically help you prep for your exam. But that said, let's go ahead and get started. Bernadette, I knew I loved you. Cowboys fan through and through. Awesome. And you are prepping for the you're prepping for the Praxis 5165. You did horrible on a practice test. Girl, you've got this. Do not let your mind take over because a lot of times our mind, now, you may still need to do some prep, absolutely. But sometimes when we let our mind let us believe that we can't do it, that's where a lot of people struggle with passing these exams. Hey, Arlene, good to see you. I did get your question. Now, Arlene found me on Facebook. She messaged me, she DM'd me a question, and it is in our set of questions tonight that we will be solving. So I'm super excited. Like I said, if you have any questions, don't hesitate to ask. It makes this a little bit more fun, and it tailors it to what you need. So let's get started with the first question. All right. Now, this is a question that someone asked for in the past few weeks. Someone specifically asked for linear functions. So, a table of values that represents a function is shown below. Determine the end behavior of the function. Now, we don't know if this is a linear function or if it's a cubic function or if it's a square root function or if it's a quadratic function. Could we figure that out? Absolutely, we could. But we don't need to because all they want to know is the end behavior of the function. All they want to know is the end behavior of the function. So that means they want to know what the ends are doing of this function. So as I look at my x values and my y values, we're evaluating two different things. So when I look at my answer choices, and I'm always going to look at my answer choices, even just very briefly, before I start solving my problem, because looking at the answer choices helps me know what they're asking for. So when I look at these, they all say as x values increase or as x values decrease. What are the y values doing? So they're saying as x gets bigger and bigger and bigger, or as x gets smaller and smaller and smaller, what is that y function doing? What is the end of my graph doing? So let me give you an example. Here's a graph. And here is my function. This is a total example just so that I can explain what this means. So when I look at this, as x values are increasing, which means as x values are getting bigger and bigger and bigger and bigger and bigger and bigger and bigger, what are my y values doing? What is the end of my function, which is end behavior, doing? My y values are increasing. They're going up, 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 and away. So as my x values are getting bigger, like into the hundreds and millions and trillions, my y values are continuing to go up. So as x values are increasing, y values are increasing. Now, that's not our example. So let's go ahead and take a look at our table of values. So we have -1, -6. I'm going to very roughly sketch this just so we can see it. 0, 5, 1, 4, 3, 2. No, I am not graphing this correctly. Yeah, I am. Over 0. No, I'm not. I should be having tick marks. Lordy, I am sorry, y'all. Okay. -1, +6. over 0 up 5, over 1 up 4, over 3 up 2, over 5 up 0. So this is a linear function, and it's going like this. So as my x values increase, what are my y values doing? My y values are decreasing. So as my x values are getting bigger and bigger and bigger and bigger, my graph is going down. So as x values increase, my y values are decreasing. Does that make sense? Awesome. So understanding end behavior is definitely something we need to be aware of in middle school and high school if you're taking one of those exams. All right, I'm going to flash the next problem up, and I want you to take 10 seconds to read it and think about how you would solve it, and then I will be right back. So you're going to think about how you would solve this problem, and then I will be right back. All right. What'd you think? Now, Bernadette, do not be panicked. Panicked on the first problem? This problem? Is that which one you're talking about? I know. That's what I need you to realize, and not just you. And I love that you're being vulnerable in the comments. I need everybody to realize this. People freak out over problems like this because you see a table of values. You're like, oh God, a bunch of numbers. And then you see end behavior and you think, I don't know what end behavior is. What is end behavior? I've never learned that before. But when we stop, pause, breathe, and think, we begin to realize we have a lot more knowledge than we think we do. Let's run with that. All right. So going back to the problem that I left you with before I had to run away. A picture is to be printed on a sheet of paper with dimensions of 8.5 by 14 inches. A margin of 0.75 or 3/4 inches is to be left on all sides of the picture. What is the area of the printed picture? Round to the nearest tenth. This is a problem that a lot of people would be panicked about because there's a lot of words, a lot of vocabulary, and they don't know where to start. I do this problem in almost every one of my tutoring sessions because people get so overwhelmed by it. Let me show you. Let's draw a rectangle. Anytime that I see a geometry problem, I'm going to draw a picture. So a picture is printed on a sheet of paper with these dimensions. So let's draw that. A sheet of paper with 8.5 by 14. A margin, what does margin mean? Yes, Joseph, absolutely. If I could give you a high five, I would. A margin means how much space is left on the top and the bottom and the right and the left. So I'm going to draw my margin of 0.75. So this is 0.75, this is 0.75, this is 0.75, and this is 0.75. What is the area of the printed picture? I'm going to pause and I'm going to think, how do I find area? Area equals length times width if I'm thinking about a rectangle. Now, that is not the case for a triangle or a circle or a trapezoid. We have to know our area formulas. If you are taking the GK, you get a reference sheet. If you are not taking the GK, I don't have that memorized, so you can use your study companion or your blueprint to figure out if you get a reference sheet or not. The reference sheet for the GK does have all of these area formulas outlined, but if you don't know how to use them, it's not super helpful. So length times width. So I'm going to do length times width. However, that is not 8.5 times 14. Why? Because 8.5 times 14 equals the whole paper. And we don't want the whole paper. We want just the printed picture. So how do I find out what this measurement is and what this measurement is? We need to do a little bit of subtraction, right? So what am I going to subtract? I'm going to do 8.5 minus 0.75 minus 0.75. And you're saying, Amy, I don't understand why you minus 0.75 minus 0.75 again. Why do you do it twice? It's a great question. Because if this whole thing is 8.5 and I want just that section right there, then I need to subtract out this 0.75 and this 0.75. So 8.5 minus 0.75 minus 0.75 is, I'm using my handy dandy calculator because I don't want to make a calculation mistake. 7. Well, that was easy. So this side is 7. Now, I'm going to do the same thing for the 14. I'm going to do 14 minus 0.75 minus 0.75 because, again, I'm not looking for this entire piece. I'm looking just for this piece, which means I have to subtract out this section and this section, which we know are 0.75. So 14 minus 0.75 minus 0.75 equals 12.5. So I'm going to do 12.5 times 7, which gives me 87.5. If I did 14 times 8.5, I would have gotten 119. Okay? Now, here's one of the most common mistakes people are going to make. One of the most common mistakes people are going to make is they are going to subtract only 1.75. So they're going to do 8.5 minus 0.75, and that's it. That is the most common error on this kind of question. And not for lack of understanding or knowing, but just because that's what our brain tells us. Because it's like, oh, 0.75 around all the edges. I'm going to do 8.5 minus 0.75, 14 minus 0.75, and run with it. So that's what most people will do. Yeah, absolutely, Bernadette. That's the most common mistake, which is why that's one of the answer choices. All right, let's go to another problem. What is the equation of the line that is parallel to y equals 3 and passes through -2, 6? When I look at my answer choices, I see very similar answer choices. I see 2 in slope-intercept form, and I just see 2 that are just y equals. Here's what most people are going to choose. Most people are going to choose one of these because those look more like equations of lines, right? We are so used to equations of lines being either y equals mx plus b or y equals, no, not y equals, y minus y1 equals m times x minus x1. And so if people don't understand what this is asking, they're going to jump the gun and choose A or B because it looks familiar, which is totally understandable. However, I want you to think about a line that is parallel to this line. What does that line even look like? What does the line y equals 3 look like? Well, let's think about where y equals 3. Where is y going to equal a value of 3? Absolutely, Joseph, a horizontal line at y equals 3. And y equals 3, we go up 3, 1, 2, 3, and we draw a horizontal line there. However, a lot of people assume that y equals 3 is actually right here. That is a common misconception, and here's why. That is an extremely common misconception because we look at the y-axis and we think that it's up and down. So we think that a y equals line has to be vertical. However, what I want you to consider is this. What are the values of the points on this line? What is that point, and that point? If we write down what those points are, this is 1, 3. This is 2, 3. This is -3, 3. So what I want you to realize is this. No matter what, I'm going up 3, which means my y value is what? 3. So therefore, that's why a y equals line is horizontal and an x equals line is vertical. So that said, what is a line that is parallel to this line going to look like? It's going to be a horizontal line as well. And it's going to be a horizontal line at y equals something. Well, if it passes through -2, 6, we're looking at this point right here. And if it's a horizontal line that goes through that, what is it going through? +6, because that's the y value. So this is going to be y equals -6. Does that make sense? All right, y'all are doing great. Let's go ahead and keep going. So now, this is a thick problem because it's got a lot of words. I tell students to follow the tick marks on the graph. That way there is no confusion. That's a great strategy, Joseph. I love that. All right, let's go ahead and look at this problem. Sabrina knows that she can paint a rectangular wall that measures 8 feet by 12 feet in 1.5 hours. She estimates that it should take her about 3 hours to paint a wall that measures 16 feet by 24 feet. Is Sabrina's estimate reasonable? A. I don't know why it says 1. We're going to call these A, B, C, and D. A. Yes, because doubling the size of the wall will double the amount of painting time. B. No, because Sabrina will be able to paint a longer length without changing direction, resulting in a shorter painting time. C. Yes, because when the perimeter of the wall is doubled, the total distance that she is painting needs to be doubled. No, because doubling the dimensions of the wall will increase the area of the wall by 4, resulting in a painting time of about 6 hours. This is a lot of words, and what I want you to realize is it's not a hard problem. Let's talk about it. Let's draw our 2 walls. So here's my first wall, 8 by 12. And here's my second wall, 16 by 24, right? And so what happened was I doubled this side right here from 8 to 16, and I doubled this side right here from 12 to 24. So it only makes sense that when I double the wall, the painting time is going to double. However, we're not technically doubling the wall. We are doubling the perimeter, which doesn't mean that I'm doubling the area of the wall. This is where we get into scaling and where we get into understanding how changing dimensions of a shape changes drastically the area and the volume. So what we like to talk about is this, and this is not how long I would take to do this problem, but I'm giving you a lot of background because scaling is difficult for a lot of people. When I look at the perimeter of a shape of a shape, we're talking about a linear measurement. When we're talking about the area of a shape, we're talking about the square measurement. How many little squares are inside that shape? When we're talking about the volume of a shape, we're talking about how many cubes are in the shape. So it's considered a cubic measurement. So by doubling the sides of the wall, let's see how it affects painting time. So the area of this wall is 8 times 12. What is 8 times 12? Let's use our handy dandy calculator. 96. And what is 16 times 24? 384. Already we see that this and this are not doubled or halved. 384 is not double 96. Double of 96 would be 192. That's not double. 384 is not double. 384 is quadruple. 96 times 4 equals 384. So the most common error people are going to make is they're going to choose C. And again, that's okay. That's why we're here. We're talking about these common mistakes. This is going to be the most common mistake people make because they just think if I double the sides, I'm going to double the area, which means I'm going to double the amount of painting time it's going to take. But that's not true. Doubling the sides increases the area of the wall by 4, which means that we are looking at an increase in the painting time to 6 hours because 1.5 times 4 equals 6. Now, why does that happen? Well, let's take a look at why that happens. Well, everything just froze. So maybe we're not going to take a look at why that happens. Well, my notability just completely froze out on us. So we are going to close out the program and restart it. So hold please for 1 minute while I close out the program and restart it and see if that helps. Beautiful. Okay, so why does that happen? Because and it just froze again. So we're not going to talk about why that happens. It happens because if I think about a rectangle that has dimensions of, we can do it right here. If I have a rectangle right here that has dimensions of 2 by 3, and actually let's do a 3 by 3 because I don't like using the number 2. So let's say this is a 3 by 3. And I double that, which means it's now a 6 by 6. Watch what happens. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6. By increasing this and this, I'm increasing it in multiple directions, which is why the scaling doesn't just double, it quadruples. Does that make sense? All right, let's go ahead and move on to the next problem. Now, someone specifically asked last week for a problem that consisted of student errors, specifically in the Praxis elementary exam. So they wanted to see me solve a problem specifically related to student errors in the Praxis elementary exam. So that's where this problem is coming from. Again, y'all, send me problems that you want me to work on. Send me topics or categories that you want me to focus on. That's what helps you. So Alana's teacher asked her to count out 4 red counters. Alana counted 4 counters. So I'm going to draw 4 counters just so I can visualize this. 1, 2, 3, 4. Yes, Joseph, if you're talking about the boot camp, we are working on getting student analysis and classroom errors and all of that into the boot camp. Then Alana's teacher asked her to add counters to her pile of 4 so that the pile would have 9 counters. So we're looking for the pile to have 9 counters. So we need to add 1. We already have 4, 5, 6, 7, 8, 9. Alana counted out 9 more counters and added them to the pile of 4 counters, resulting in 13 counters. So Alana did 1, 2, 3, 4, and then she added 9 more. 1, 2, 3, 4, 5, 6, 7, 8, 9, which equaled 13. Which of the following most likely explains the reason behind Alana's error? A, Alana does not fully understand one-to-one correspondence between numbers and objects. B, Alana does not yet know her addition facts for sums greater than 10. C, Alana does not understand the quantity of 9. Or D, Alana does not yet understand that one quantity can be composed of 2 smaller quantities. So, which one explains why Alana is wrong? Now, here's the thing. Maybe Alana has issues with one-to-one correspondence. Is that possible? Absolutely. Maybe Alana doesn't understand what the number 9 is. Probably not, because she was able to count to the number 13 accurately, but maybe that's the case. But listen, hear me out. We're looking for the most likely response, the most likely explanation for why she has an error. So we need to really think about where her error was. Does she have one-to-one correspondence? Probably, because if she can count 4 and 9 more and get the answer 13, she has one-to-one correspondence. Here's what one-to-one correspondence is. The ability to know that this is 13 because you're going like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. When a kid doesn't have one-to-one correspondence, it often looks like this. 1, 2, 3, 4, 5. Or it might look something like this. 1, 2, 3, 4, 5, 6, 7, 8. It's just the inability to know that one number goes with one counter and that two numbers go with two counters, and that as I go further and further along the continuum, as I say another number, I only add one more counter. So to go from 1 to 2, I'm just pointing to one more counter. A kid that does not have one-to-one correspondence will often swipe their finger across or go too fast, or because they just don't understand that when I point my finger to this, that's 1. And then when I point my finger to this, I'm adding one more. So does Alana have that? Probably, because she was able to correctly get to the number 13. Now, if it said Alana's teacher asks her to count 4 counters, or no, Alana's teacher asks her to count these counters. Alana says there are 3 counters. What is the most likely reason? Probably because she doesn't have one-to-one correspondence. So she's going like this. 1, 2, 3. Okay? That would be a one-to-one correspondence issue, not the one we're exhibiting right now. B, Alana does not yet know her addition facts for sums greater than 10. Maybe she does, maybe she doesn't. But she certainly got 4 and 9 more equals 13. So that's not our issue. Alana does not understand the quantity of 9. Alana most certainly understands the quantity of 9 because she's able to add 9 more to the number 4 and get to the number 13. Alana does not yet understand that one quantity can be composed of 2 smaller quantities. Here's the thing. If you don't even know what that means, because that's a lot of words, what you do know is that A, B, and C are wrong. So I would confidently go with the letter D because I'm so confident that A, B, and C are wrong, even if I didn't know what D meant. Now, if I didn't know what D meant, but I also wasn't sure about B, that's where you get into a sticky situation, because then it's a 50-50 coin toss. But in this situation, I am 1,000% confident the answer is not A, B, or C, and so that means it's D, even if I don't understand it. Let's talk about what D means. So what they wanted her to do, what they wanted her to do was have 4 counters. Let me do it in red and keep it consistent. And then the teacher wanted her to add more counters so that she had a total of 9 counters. So what we're looking is a part, whole. We're looking at a part, whole. So what that means, if we're looking at a part, whole, is that the whole number, the number 9, is composed of 2 smaller pieces. It is 4, and then it is 5 more. Kids often have a difficult time with this concept because they don't understand that 9 is my whole. They don't understand that I'm breaking 9 apart into 4 and another part. Does that make sense? That's why she didn't get this problem right, because she conceptualized 4 total, 9 more total, and then it results in 13. Okay? All right, let's go ahead and move on to the next problem. Okay, this is a problem that was specifically submitted to me because someone was struggling with how to solve it. And so I love being able to do these kinds of problems because it helps you out. Jason draws a circle. What am I going to do before I even read the rest of this problem? You got that right. Draw my circle. There's a circle. Then he draws 2 radii and connects the 2 radii with a chord. Now, here's the problem. If you don't have a schema for the vocabulary in this problem, you're going to struggle. So if you don't understand what these vocabulary words are, you're going to really struggle with this problem. So he draws 2 radii. What are radii? Radii are lines that go from the middle of the circle to the outside of the circle, and it hits the outside point. So if this is the middle of my circle, that's a radii, 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 that's a radii. Those are all radius or radii. So that said, all radius are the same length. All radius are the same length. So he draws 2 radii. So I'm going to draw 2 radii. 1, 2. Does it matter what kind of radii I draw? No. Could I have drawn something like this? 1, 2. Absolutely. And then he connects the radii with a chord at the points where the radii intersect the circle. That's all that means. He connects the radii with a chord. A chord is just a line that's going from one end of the circle to the other without going through the middle. And it's where they intersect the circle. What kind of triangle is formed? I could also do it here. Right? Those are 2 very different triangles, but they are the same classification. This is an isosceles triangle all day long. Here's why. Because this is a radii and this is a radii, which means they are the same length. This is a radii and this is a radii, which means they are the same length. An equilateral triangle has 3 congruent sides. An isosceles triangle has 2 congruent sides. A scalene triangle has no congruent sides. And a right triangle creates a right angle, but it could be an equilateral or an isosceles triangle. Now, Arlene, that is an excellent question. Could I not create an equilateral triangle? Could I? Absolutely. Could. Now, the blue triangle looks more like an equilateral triangle, right? Could the blue line be the same length as the radii? It could. Is it the same length in this pink triangle? Absolutely not. That pink cord is way longer than my other 2 radii. So this is definitely not an equilateral triangle. This could be an equilateral triangle, but what we have to do is say for certain what is created. For certain, we have created an isosceles triangle. Now, it is an equilateral triangle. Technically, could we call it an isosceles triangle? Sure, because there's 2 congruent sides. So every equilateral triangle could technically be called an isosceles triangle because there's 2 equal sides. However, not every isosceles triangle is an equilateral triangle. Same with the right triangle. Could this create a right angle? Yeah, absolutely it could. However, this is not a right angle. So I created an isosceles triangle that is not a right triangle or an equilateral triangle, but every single time, no matter what I do, when I draw 2 radii and connect it with a chord, it will always be an isosceles triangle, okay? So that's hard. That's a hard one, and I need everybody to hear me out on that. Arlene, you made an excellent learning point for the rest of us in this room, and I love that you did that. Could it have created something else? Yeah, it absolutely could have. But when we're solving these problems where they're trying to trick us, then when we're solving these kinds of problems, they want us to get into our mind space and get into a space where we start to think, well, it could be this or it could be that. You're only going to choose the answer that's the absolute in this kind of situation. Now, that's kind of weird for me to say because when you're taking a test, you often want to avoid absolute situations. You know what I mean? Like, you often avoid sentences that say never or always, because when we're looking at like a professional ed test or something, and Dr. A talks a lot about this, we want to avoid that. However, on this kind of problem, we're looking for the kind of triangle that always happens no matter what. Joseph, you make an excellent point. You make an excellent point. A lot of people would draw this triangle. Why? I don't know, but that's the one I drew first because we're not going to, it just looks better in our brain. A lot of people are going to draw the pink triangle when they go to draw it. Or how about this? What about this green triangle I'm about to draw? That's still a triangle, and it's still isosceles, absolutely. But that's not the first triangle I go to draw. I'm going to draw that blue triangle all day. Bernadette, do some of the questions on practice 5165 have multiple answers? I don't know the answer to that question. So you know what I'm going to do? I'm going to snap a picture of your question so that I remember to answer it. And what I'm going to do is I'm going to look it up for you. I'm going to find out, and I will answer that question next week. And in fact, if some of them do have multiple answers, I will have some questions next week that have multiple answers. Joseph is saying yes, and fill in the blank. So there you go. There's your answer. They do have multiple answers, and they have fill in the blank. So you know what? We'll do a couple of those next week, okay? TJ, you freeze up on these tricky questions. We all do, to be quite frank. We all freeze up on those kinds of questions, which is why we're all here tonight, to really work together. All right, let's go ahead and solve another problem. Two angles are complementary. If you don't know what complementary angles are, this problem is going to be really, really difficult for you. One of the angles has a measurement of 54. What is the measurement of the other angle? A, 36 degrees, because the sum of two complementary angles is 90 degrees. B, 126 degrees, because the sum of two complementary angles is 180 degrees. C, 306 degrees, because the sum of two complementary angles is 360 degrees. D, 54 degrees, because complementary angles are congruent. I have a secret for you. This problem requires no math at all. This problem only requires that you know the definition of complementary angles. I'm going to show you why. And I want you to start to try to pay attention to these kinds of things on these exams. If we look at this, they're telling us that two angles are complementary. But then when we look at the answer choices, it says the sum of two complementary angles is 90. The sum of two complementary angles is 180. The sum of two complementary angles is 360. Complementary angles are congruent. Which one is it? If you know the definition of complementary angles, you don't need to do the math, right? Complementary angles, complementary angles have a sum of 90 degrees. Therefore, the answer is A without doing any math at all. Supplementary angles have a sum of 180 degrees. And angles in a circle add up to 360. And angles that are congruent are congruent. There's nothing else to say about it. So because we know that complementary angles add up to 90 degrees, there's the answer. Now, if they had 2 or 3 answer choices that said the sum of two complementary angles is 90 degrees, then we would have to do the math. And all we would do is 90 minus 54, and we would get an answer of 36 degrees. All right, next problem. Ooh, this is a good one. Jason is trying to figure out the perimeter of a rectangle that has a width of 5x minus 4 and a length of 2x plus 9. What is the perimeter of the rectangle that Jason is working with? Copy and paste the link. What do you want me to copy and paste the link to? I'm sorry that I'm not sure what you're asking. Jason is trying to figure out the perimeter of a rectangle that has a width of 5x minus 4 and a length of 2x plus 9. What is the perimeter of the rectangle he is working with? So what am I going to do? We've done a couple geometry problems tonight. You should know we're going to draw this rectangle, right? So here is my rectangle. Oh, you're welcome. I'm sorry. All right, here is my rectangle. And I know that one side, the width is 5x minus 4, and the length is 2x plus 9. What I want you to realize when I look at my answer choices, because I'm going to take a quick glance, is that my answer choices don't give me numbers. That's okay. Think about, what do I do to find perimeter of a shape? Perimeter of any shape. Doesn't matter what the shape is. As long as it's 2D, we add all sides together. There is no special formula. Now, when you look at a formula page, is there going to be a special formula? Yeah. Sometimes they'll be like P equals 2 times L plus 2 times W. Why memorize a formula that we don't need to memorize? The perimeter of a rectangle is technically this. However, I can just go this plus this plus this plus this and call it a day. So I choose not to memorize things that are not necessary, right? So that said, I am going to add this plus whatever this is plus whatever this is. So I have 5x minus 4 plus 2x plus 9 plus, what is this side equal? 5x minus 4, because opposite sides in a rectangle are congruent or equal. What is this side going to equal? 2x plus 9. So I'm going to add 5x minus 4 again, and I'm going to add 2x plus 9 again. Now, I put parentheses around it because these are expressions. And when I add or subtract expressions, I'm going to keep them together until I'm done. Now, addition is commutative, so I don't need these parentheses. So I'm just going to write 5x minus 4 plus 5x minus 4 plus 2x plus 9 plus 2x plus 9. Again, addition is commutative, which means I can add in any order. I'm only going to add things that are alike. So I have my x's, and then I have my constants. 5 plus 5 plus 2 plus 2 is 14x. I'm not going to go any further. I immediately see that 14x is letter B, so I'm going to stop and freeze there. Now, 9 plus 9 is 18. 18 minus 4 is 10. So yeah, we can finish solving it. If I can save 15 seconds right there, I'm going to. All righty. So here's what we're going to do. I want you to think about what else you want to see me solve in the upcoming weeks. I want you to drop it in the comments. What kinds of problems are you looking for? Or are you going to email me or Facebook me some questions that you have? And if you don't have any, that's okay. You can still come, hang out with us, do all the math problems that I'm going to bring with me. But if you have specific things that you're struggling with, please let me know, all right? And let's all say good luck to Arlene because she is taking her test this weekend. So we all wish you good luck, Arlene. You got this. Remember, it's not if you pass, it's when you pass. We're all sending you good vibes. I'm super excited for you, and I know you're going to do great. All right, before I turn it back over to Dr. A. I want you to drop in the comments what you want to see me solve. I'm definitely going to include some fill in the blank and multiple answers. But if there's anything else that you want to see, please let me know. Otherwise, I am going to go ahead and turn it. Oh, and Lauren, I'm going to include Comp 1 and Comp 2. In fact, I'm going to write that down on my PowerPoint this week so that I don't forget. So GK, Comp 1 and 2, multiple answers, and anything else you guys email me or comment or shoot me in Facebook. All right, Arlene, good luck. You've got this. I'm going to turn it back over to Dr. A, but I'll hang out in the comments for just a little bit longer. I hope you all have a great week. And if you're watching the Super Bowl, have fun on the watching the Super Bowl. All right, y'all, turning it back over to Dr. A. Bye.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you use the coupon code, all capital letters, SINK35, that's SINK 35, that will take off 35% off any of our prep courses on our website at the Learning Liaisons. It doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.